Hello everyone, we are the Team GSPs, that stands for Game and System Programmers. And our topic for today is classes in Java. My name is David Marcellus.
And my name is Zachary Gropey. Let's get to it.
So OOP, or Object-Oriented Programming, is a programming paradigm based on the concept of objects which can contain data. There are 4 OOP fundamentals: encapsulation, abstraction, inheritance, and polymorphisms. But in this given time, we'll actually only talk about encapsulation.
So encapsulation in Java, as well as in other programming languages, is a mechanism of wrapping data or variables and code acting on such data or methods together as a single unit. Why we use encapsulation, and first off, is that to make larger programs more efficient, shorten your main method, as well as use objects instead of groups of individual variables. And so the main components of encapsulation is that of member variables and functions that make such classes unique or objects unique, as well as the info hiding mechanisms that essentially act in specifying what can be accessed outside of a class itself. And there's really 2 parts of access specification that we focus on in mainly, is that of private access specification as well as public. Where private is that of something that cannot be accessed outside of a class by itself, where then public is able to be accessed outside of a class by itself. And our kind of our workarounds to gaining access to some of those private member variables outside of the class, as well as there's also the protected access specification, but that's honestly just really a modified version of public.
So in here, there's here's one example that we are trying to make a person object. So the first thing we do is we separate like 2 things: the state or properties and behavior or actions. So an example like black hair, black eyes, white skin, 6 feet tall, and 5 kilograms are considered as the state or properties, or descriptors you can say, this because it describes the person is. And behavior and actions, we can say like the things that the person can do, such as eat, sleep, walk, play, and study.
And so then moving on from that, we have our Unified Modeling Language Diagram, or UML diagram, to really show how we're going to use what we previously gone over in a class with this rectangle object. And so we have a few parts of this thing. We have descriptors, which are found in the yellow section there, essentially our member variables to the 2 parts of the rectangle, width and length. We're not going to focus on anything else. And we have actions, that being found in the green section with all the different operations and other functions that can utilize those previously defined variables. Like creating the object, setting those certain things, getting certain values, or conducting other advanced operations with area and perimeter. And then you have access specification or access modifiers, which can be found through the minus sign for those of private member variables, which are typically variables, just since we don't like those getting access outside of a class. And then we have those of public, which are signified with the plus signs, using those operations to be the middleman between using these member variables outside of the class. And we have parameter list for some of these functions, mainly none of the getters, but in the setters in the constructor, just to get these initial values to our member variables here. And for those, then there's also return type after that, which for a majority of the top 3 functions we have right here with the constructor and the setters, going to be void, since they're not going to be doing anything outside of that of just getting a value to the member variable itself. While then these getters and stuff down here actually be doing an operation, and we're wanting to return the value based off the operation, either that being pretty simple, which is returning the width and length, or actually conducting an operation and then returning the result from that. But with these several things, let's actually get into our little demo and showing off both that of not using a class and then using a class with rectangles. Let's move on to the demo.
Alright, y'all, now we're gonna go over some demo. So the first thing we have to do is type Java Online Compiler in your browser. Java Online Compiler, or you can do with your own IDE or integrated development environment, such as NetBeans or Eclipse, and I will put like the link to download below. And after you type Java Online Compiler, you can click the 3rd one. This one's pretty easy to use. And now in this, I'm just gonna do an example without class, with the same example that Zach told us before, a rectangle. So the first thing we do is we declare the descriptors, which is width and length. So double width equal to 2.0 and double length equal to 3.0 maybe. And then I just want to see if it is there, so I just put I'm gonna print it with system.out.println so width plus width, and same thing with the length. I just copy and paste it, and then just write it right here. Okay. Oh, it's so long. Okay. Hello world, width equal to 2.0 and length equal to 3.0. So we're good. And now I'm gonna try to find the area and the perimeter by declaring a new function or method. So it's gonna be public, should be outside of the main function, remember, because this is a new function. So public static and the return type, which is double in this case, and then the function name get area with the parameter list, which is double W for width and double for L for length. And in this we can actually declare a new variable area equal to W times L, or we can just simply return W times L semicolon. So in here we can print the area, give it space, okay, area equal to, and call the function from the main with, so W is the first parameter, so it's gonna be width and length, and if you run it again we should get 6.0 there. 6.0, okay. And now I'll make another method for get parameter. So remember, public static and return type, get parameter. We can just copy and paste this because it's gonna be the same. So in here the return type is gonna be double, and the formula for the perimeter of a rectangle is 2 times W plus 2 times length. And if you want to make sure, you can just put parentheses there. Oh, okay. And then we'll print it again. System.out. I just copy and paste this. Perimeter equal to get perimeter width and length. Should be 10. Yes, 10.0. Yeah, I got 10.0. So now here's the problem. If I want to make another instance of a rectangle and want to see like the area and the perimeter, I have to declare a new variable. Let's say width 2 and length 2 with another number, for example like 4 and then 5, right? And then I have to do this again, all of this again. So in here, width 2 equal to width 2, length 2, area 2 and perimeter 2, and change all the parameters here. 2, get area with width 2, length 2, and get perimeter with width 2, length 2. Yeah, that's a lot of work. And then see, let's check if everything's alright. Yeah, I think it's alright. And if we run it, then we can get the new area and the new perimeter. Yeah, right here, area width 2, length 2, with all that stuff. And if I want to make another rectangle, I have to do this all over again with like width 3 and length 3, and then area 3 and perimeter 3. So that's why it's not really like convenient to implement this. That's why we have encapsulation with classes. It's gonna be like really easy, and Zach will show you how to do that.
Hey everyone, now it's time for my part of the video demo, but before I get into actually making classes, let's go over why we need parameters right here. So essentially in this case, if we're wanting to access a function outside of a main, we need to be passing we need to get our variables that we're focusing on to the actual function itself. And through passing them by value, like we're doing right here, we're using these temp values to essentially replicate our width and replicate our length to actually be able to conduct the operation. Because if we just did return width times length right down here, it's going to give us an error because width and length don't have any scope beyond just this main function. So through passing by value through the use of parameters right here, we're able to get our width and length values to the function to do the operation. And so that's essentially with that. And just in case someone had a little bit of a question about it. So from here, let's move into actually making our class. But before I get into programming, let's go back to these slides to focus on what we're going to use for our object. So in a rectangle object, we're going to have a couple things: our private member variables, width and length, and then with their public member functions, I mean doing the operations and actions with the actual class. You know, with your constructor, your setters, your getters, and your additional getter operation functions. So with that, let's get into programming it. And so when making a new class, we're going to be just adding another file, and we're going to name our file the same thing as our class name. So we're going to make it rectangle.java. And so then we're going to be making class rectangle. And just doing this such. And first we're going to start off with our our private member variables. So we know that we need two things. We need a private double width and private double length. If I can spell it correctly. And then from here we're going to be moving into our constructor, which is pretty simple. So we're just be making a public, since it's not returning any. Well, it's public because that's its access, as well as then it's not going to have any return types. So we're not going to specify one. Name it the same thing as our class, since we're using it in object creation. And we're making also some parameters for this, since we'll be using this whenever we create the object itself. So we're making the same thing, double width and double length. So then in this, when we actually assign these versions of these versions of the variables, we're going to be using the this keyword to specify what width and what length we're using. And just doing this specifies that we're using the class's instance of the width. We're not focusing on the width right here. So then we're doing the same thing for length. And so essentially that's it. That's going to be our constructor to set up our values for our member variables of the class to their default value through the use of the constructor. Now let's get into our setters, which are essentially going to be the same thing but cut in half. This time we're going to specify that they are void, that they're not returning anything. Set width with double width. And this is going to be not returning anything, and we're doing the same thing. Actually, let's just make this simple. Paste this down here because it's the same operation that we're doing. And then we're going to do the same deal. We're going to do then this with the length. So there's just a few things that change. Name of the function, name of the parameter, and then right yaw. Sweet. And so then those are our setters. Essentially doing the same operation as the constructor, but just able to reset these values to different things in case we want to in the main. So then let's make our getter functions, both returning double and just get width. We're going to start off. In this case, we're not needing any parameters, since the actual width value, almost as a variable, is tied to the class. We're focusing on the version of width in the class. So we're doing return this dot width, and that's it for the get width, because we're returning the value width to a specific location, not printing it, but returning it. And then doing a similar thing with the length. Just change a few things. Name of the function, name of the value actually returning, since we're returning width this time, or not length this time. And then those are our getters. Simply just returning the current version of these member variables to wherever they're called. And then now getting into the different operation-based functions, area and perimeter. Let's get into that of making a double get area, again with no parameters, since we don't need parameters in this case. Actually, I'm gonna make this a little bit easier. Just remembered. Go back to what David had, but we're gonna change it just a tad. Bring it back in here and bring it in. I don't know why it's looking all funky like that. So we're gonna get rid of the static because we don't need a static. And we don't need the parameters since since the width and length are actually a part of the class, and we don't need to do anything extra crazy with them. Or we don't need to make temp values to stand for them. And then do the same thing for perimeter. Go back to what he had. Plugging them in here, getting rid of static, getting rid of the parameters. Nope, I don't want that. And then just doing it like we did last time, focusing on this dot width and this dot length. Focus on the class, the current instances version of width and length. And so essentially that's it. That's going to be getting our area and perimeter functions in the class with the specified versions of width and length. And so with that, let's start to plug this into the actual main class, or main function. And so to do that, we need to do one simple thing. Create the instance through the use of the constructor that we just made in the class. All right, so let's do making an object rectangle with the name of the object, which we're just going to keep it simple with R1. And then equal new, use the new keyword, creating a new instance of the rectangle through the use of the constructor, then with the two specified parameters that we're passing in for the values. Let's keep it the same as what David already had here, 2.0 and 3.0. Making essentially the same rectangle, but in one line with the same width and length. And let's do the same thing for his other example. Put the same values back in there, rename it. And essentially what this is doing, at least in this instance, is shortening down this whole, making the new variables and stuff in the main into just one single line, where all the data is consolidated to just the class and not anything actually in the main here. So let's duplicate this stuff and bring it through the use of the class, which is not bad. So call it class stuff. And so for this, we're going to change these a little bit more, and because the reason how we're going to be able to do that is through the use of our actual name of our current object, or our rectangle object, in the function that we have. So remember in here we have our getters right here, get width and get length. That's what we're going to be doing in our print statements. So instead of just width right here, we're going to do an R1 to specify what rectangle we're focusing on, get, and then change that to W, uppercase W, and then put that to make it a function, so that we know exactly what we're printing. We do the same thing for that of the length. Get length. All right, and so essentially this is be getting R1's, or rectangle 1's specific width and length for this. And then let's do the same thing for the area and perimeter. I almost forgot. So then we're going to do, get rid of the parameters since we don't need them, and then just do an R1 dot get area, simplifying it a lot, since we're not trying to, since remember in this main class we aren't able to actually do direct access to our member variables. And so essentially this is going to be the class version of doing the same thing of printing the width and length of the rectangle, as well as getting the area and perimeter. Let's make sure we do the same thing for our second rectangle. Just need to change the number that's right here, and it also depends on how complicated you want to make your object names. But just to keep it simple in this case, I kept it to R1 and R2 to specify what rectangles we're looking at. And so then this is it. We have our class versions of rectangle through the use of the new operator and the constructor to create essentially the same rectangle, but in a consolidated way. Use their member functions through this, and essentially cut down on a lot of stuff that we put in the main. So let's run it and make sure that we have no errors, which there shouldn't be. I got a compiler error, of course. Yeah, okay, I probably forgot something right here. Something simple. Always gets you. No, I don't want to leave site. Okay, so we're essentially printing out the same thing twice in a row, but now using that of a class. So that should hopefully show a little bit into how simple it is to replicate all what David did, but in a consolidated manner through a class where we're having all the member variables and functions all in a separate location outside the main. And so with that, let's now move on into the summary of our video. Alright, now it's time for the summary for this video, and essentially I'm going to go over what we did in the video. And so essentially we focused on that of data encapsulation, which is a big part of object-oriented programming, and focusing on that of making your main function a lot more efficient, more readable. And essentially bringing in, getting rid of all this, a lot of the fluff and, object-specific variables, object-specific functions, and putting them in a different location, like your class, like we had right here. And then still bringing them back for, instances of them, instance-specific functions and all that to really bring back the functionality, but to make it more efficient and, more condensed. Just because in larger scale programs, your main's going to be really big and have a lot of stuff going on. So putting all these variables and stuff like that, hundreds and hundreds of variables, it's going to make things really confusing and you're going to lose track, and it's going to be really inefficient. So that is essentially what we had for data encapsulation today. If we get 60 million likes, we're going to make our next video that of abstraction, another big part of OOP, like we said, and bring in more of that and focus on that and bring back, go into a little bit more detail about that whole subject. So thank you y'all so much for watching our video, and I hope y'all have a good rest of y'all's day. Thank you.